Unit 6, similar triangles, and day 5. Today we're going to go over parts of similar triangles. So if we know two triangles are similar, then the following corresponding parts are also proportional, okay? So the minute we see similarity, we already talked about it, you're going to set up a ratio. So our first vocabulary word is altitudes. And altitude is from a vertex to the opposite side, and it forms a right angle. And we normally call it the height, okay? Another word for it could be height, the length of the triangle. So check it out. Here is an altitude here, here's an altitude here. So when you set up your proportion, it's going to be BD, which is the altitude, over FH, which is the altitude, is equal to AB, which is the left-hand side, over EF, which is the left-hand side. So this is the proportion you're going to set up if you see there's an altitude in the problem. Take a look at your second vocabulary word is angle bisector. So it's just what it says, angle split into two sections. Here's the notation. You can see it's marked that these two angles are congruent and these two angles are congruent. Therefore, visually, you can say this is an angle bisector. So if we see an angle bisector and we know the triangles are similar, this is how we can set this up. QS, which is this segment that's bisecting, over UV, which is the segment that is bisecting, is equal to QP, left-hand side of the triangle, over UT, the left-hand side of the triangle, the corresponding side. Don't necessarily have to be the left-hand side, but it definitely has to be a corresponding side. All right, and this one is called a median, okay? So a median does come from the vertex just to the opposite side, and then you see these two tick marks. It's because it splits that side into two congruent parts. Two congruent segments. So again, similarity, similar, proportion. So HJ, which is that segment in the middle, over LN, segment in the middle, is equal to GH over KL. All right? All right, so now that we know the rules for our vocabulary, we're going to practice some problems. So problem number 4, triangle PQR is similar to triangle UTS. Okay, and this is problem number 4. So basically we want to see, okay, where is the altitude that forms the right angle? Here it is. Okay, so that's going to be my 12. That's going to be 12. Over that same altitude in the other figure, which is 15, is going to be equal to X over what? 42. Okay, and so once we cross multiply that, we should get X is equal to 33.6. Do the math, verify if there's an error, see your teacher. Okay. Triangle, angle bisectors, I'm going to talk about this a little bit more. An angle bisector in a triangle separates the opposite sides into segments that are proportional to the lengths of the other two sides. So here we go. AD over DC, bottom over bottom, equals AB, side over BC, the other side. Okay? Triangle, angle, bisector theorem, another way of doing things. All right, we're going to try problem number 7 and problem number 9. Those will definitely be our next ones. So problem number 7, of course, in your directions, you're told that it represents an angle bisector. So we do have some basic information, okay? So number 7, you're already told that KM is an angle bisector. So let's take a look. So this segment right here is an angle bisector. As soon as I know that, I'm inclined to go ahead and mark the angle so that I can see that, now they're similar, and I can set them up as a proportion. So this particular one is going to be bottom over bottom, bottom of one triangle over the bottom of the other triangle is equal to the side of one over the side of another. We're going to cross multiply and get 40x is equal to 1944. Anybody can remember something that happened in 1944? Anybody born in 1944? Well, okay. So x is equal to 48.6. All right. That's how we do these type of problems. Proportions, proportions, proportions. We're going to take a look at number 9. Number 9 can be a little bit tricky. Take a look at the picture. This whole side represents x. And so what I'm going to do is I'm going to go in here and I'm going to put in a y here. So what I'm going to do is I'm going to find the length from M to L. Okay. Once I get that, I can add it together and find the whole segment. But this is my approach. This is what I'm going to do. Okay. So I am going to do, stick with me now, 12 over y equals 18 over 30. Okay, so I have 18y, cross multiply, I have 18y is equal to 360, divide by 18, and y is equal to 20. Okay, is that my final answer? No, it is not. Y is equal to 20. The question asked, what's x? Well, x is the whole thing. So 20 plus 12 is 32. So x is equal to 32. Is there another way you can do this? Absolutely. You could have done, let me show you this, pause and write that down. And then I'm going to show you in red how to do the next one. Okay. So in red, we could have done 12 over x minus 12, because that part is going to be the other part of 12, so we have to subtract from 12, is equal to 18 over 30, and we would cross multiply and simplify and get 96 is equal to 3x, and divide by 3 and get x is equal to 32. You know, just don't forget when you do cross multiply, you're multiplying 18 times x and then 18 times 12. Just a different way to do it. All right. Well, that concludes our lesson on the parts and how to set them up when you have the actual parts. All right. So when you see problems like this on the SOL and they give you limited information, 9 times out of 10, if they're not congruent triangles and we have to state that, something about the property is telling us it is similar and you want to go with a proportion. All right. Thanks for joining.